We are discussing about ellipse. Ellipse. We have already seen how we derive or proved the equation of the ellipse. We talked about one focus and one directrix. Now we will go a step forward and we would like to talk and see how an ellipse will have two focus and two directrix. How this shape a figure will form. So this figure I am going to make again so that just you can recall those things. You must have remembered we took one point S as focus and then we made a line which is perpendicular to it, that is called a directrix. Then there is a point which is XY and we called this perpendicular from this P point to this line is PM and the distance of P from S. So we said that ratio of this point which is moving XY, so the distance of this P point from S and distance of this P point from this line, the ratio we took and we finally found this equation. Here we saw that B square will be equal to A square 1 minus E square. This was our total equation. Now let me just extend it. I am saying that this point was A, which was the internal, we internally divided this SK in the ratio E is to 1. E is the eccentricity constant which is less than 1 in the case of ellipse. S is the focus. We took A dash also because we also divided the line SK in the ratio E is to 1 externally also. So this was A dash. Then we took A dash and A and took the center of this A dash, that is this C, and we called it as, let us take it as 0 0, that C will be the origin. Then we found out the value of S which is AE comma 0. We found out the value of K also A by E comma 0. Now whatever is happening on the right hand side, let us see it on the left hand side. That is, we are going to take this XY axis is where center is the origin. Now we are taking one more point minus A is 0 and this I am taking as S dash. So CS dash will also be AE, CS will be AE. So from this A dash we are dropping a line or making a line which is perpendicular to this line. So this line is actually will be a directrix only. So now the distance of this P point from the focus and from the directrix. Now same point, if we take the distance of this point from this S dash and again the distance of this P point from another line. So if I am saying PM dash, M dash is a point when we drop a perpendicular from P to this another line, and then we have a point S dash which we assumed. So this PM dash is the perpendicular from P to this line, Z dash K dash. You can see that there is a line proper perpendicular distance, and same way we have extended this line. So this S dash PM dash is perpendicular to Z dash, and this Z dash K dash is also perpendicular to CK dash. So, or you can say the line which is passing through C is perpendicular to the line which we made perpendicular to it, Z dash K dash. These are perpendicular 90 degree. Okay. So we have CK dash perpendicular to Z dash K dash. So now this PM dash, what is the length of this PM dash? If I drop a perpendicular here, so I'm just saying this as N. So what is this NK dash? This PM dash is NK dash. So how can we find that this distance? If we can prove the distance of this point from S dash P and distance of this P from this M dash, if the ratio is equal to is to 1, then we can say easily that there is one more focus, there is one more directrix, right? So by the definition we can easily say that this, if it happens for one, it can happen for the other also, because the only thing is the point has to have a distance from a focus, distance from the line, and the ratio should be equal to is to 1. That is what is the whole story is all about. So we have an equation here, x square by a square plus y square by b square equals 1. So let me write it again. Y square and y square by b square. I am writing b square as a square 1 minus e square equals 1. Multiply both sides by a square into 1 minus e square. Multiply both sides by a square 1 minus e square. What do you get? X square. Here you will get 1 minus e square. Here you won't get anything, only y square. And here a square 1 minus e square. Okay. So this will be x square minus x square e square plus y square equals a square minus a square e square. Now I am taking a square e square. I am interchanging a square e square and x square e square. So this will be x square plus y square. I am taking a square e square on the left hand side, and this a square remains, y square on the right hand side. No, x square e square on the right hand side. E square x square, right? So now add both sides 2aex. I am by myself adding 2aex on both the sides. 2aex on both the sides. So if you see here, x square, 2ax and a square e square. What is this? This is x plus ae whole square. If you open this square, it will be only that one, and then y square only. Then you have this a square. This is again a plus ex whole square. If you open a plus ex square, ex as whole square, you'll get the same equation which you see above. Now this x plus ae whole square plus y square, you can write it as y minus 0 square. So x plus ae whole square plus y minus 0 whole square, or you can write x minus of minus ae. X plus ae I have written, x minus of minus ae also you can write. And I am taking e square common from the right hand side. So you get x plus a by e whole square. I am taking e square common or outside. So now what is this distance? This distance is distance of xy from minus ae and 0. If I take distance of x from minus a, xy from minus a 0, x minus minus plus, that is x plus ae whole square plus y square, and this is the distance. This is only p s dash. So since it's not under root, we are making it as square. This is, you can say p s dash or s dash p whole square equals an e square. What is this? X plus a. What is this x plus a? From here to here, that is from here to here, it's x. That we know because there is x y point. From here to here, I told you same distance. So this on both sides we have a. So from center to k dash, it will be a by e. It's symmetric. So this is a by e. So x, this x, and a. What is the distance? It is the distance pm dash only. It is pm dash only. So x plus ae can be written as pm, and since it's square, you can write it as square. So let me write it s dash p, and I'm taking both sides under root. S dash p equals e pm dash. That is s dash p by pm dash equals e is to 1. That is distance of p from s dash equals e into distance of p, that is the point, the locus, from z dash k dash. And this is what is s dash p by pm dash equal e is to 1. That is the definition. That is the definition of an ellipse. That is the only definition of ellipse. That means it's very clear. That is very clear that one curve was already being made, but now we are getting another points also which are following the same relationship that we have devised for an ellipse, a conic section. Don't go on my handwriting and diagram, it's not so good. Okay, so s dash is minus a comma 0 is the second focus. First focus is ae comma 0. So these are two focus. One directrix is d1, one is d2. So x equals minus a by e is the second directrix. So we proved that there are two focus, two directrix. Now let us take the different parameters of an ellipse. Let me start with the vertices. Vertices means the point which we showed you at that time, a and a dash. That is where the curve meets the line joining the foci s and s dash are called the vertices of the ellipses. So this is vertex. One is vertex. When you take more than one, they are called as vertices. So this was 0, 0 as we assume. This A will be A comma 0 and then A dash will be minus A comma 0. I am talking about an horizontal vertex. I am talking about horizontal this ellipse. Okay. So major and minor axis now. Major and minor axis. So x square by a square plus y square by b square equals 1, where this a stands greater than b. When a will be less than b, it will not be this type of, this will not be horizontal ellipse, it will be vertical ellipse. So the major axis, this was a, this was a, from here to here it was a, from here to here it's also a, and this was b, and this is also b. So what is the major axis? A plus a, 2a. Major axis length is 2a. And what about minor axis? It's b and b, 2b. 2b is the length of the minor axis. So two more things will come: semi-major axis, semi-minor axis. Just divided by 2. That is half of this. Half of the axis. So major axis, if semi-major will be 2a by 2, that is a. Semi-minor will be 2b by 2, that is b. Now coming to foci. Let me write it as foci because it is not focus, 2 is there. So foci we have already seen S and S dash. This was minus AE 0 and this was AE comma 0. So this focus will be AE, first will be AE comma 0, S dash will be minus AE comma 0. Then we have directrices. Directrices. These are two directrices. This is D1, this is D2. So what will be D1? D1 is x equals a by e, as we have seen earlier. And so this D1 will be a by e, D2 will be minus a by e. So D1 will be x equals a by e, that is the equation. D2 will be x, this is minus a by e. So we have minus a by e 0, this is the coordinate. So x equals minus a by e. This is the directrices. Center will be 0, 0 for this particular case, because when center will not be 0, 0, then also we will talk what we are going to do about that. Okay. See, what is the eccentricity? Eccentricity, center is of course 0, 0. Eccentricity, see this eccentricity, let me take it from this equation only. So we told that we saw b square equals a square 1 minus c square. So I can write this if we want to find out the eccentricity of this ellipse, this horizontal ellipse. So we have b square equals a square 1 minus c square. B square equals a square 1 minus c square. So b square by a square equals 1 minus e square. This will be e square equals 1 minus b square by a square. So e square will be, now this this can you can write as 4b square 4a square. I am dividing both, dividing by 4. So this 4b square can be written as 2b square, 2a square can be written as, this 2a square is 4a square. So 2b by 2a I have written. So eccentricity is what? 1 under root 1 minus 2b was what? 2b was major axis. 2b was major axis. And this minor axis. This is minor axis square. Right? So this is all done, all the parts. Now two things we need to understand more. Ordinate, double ordinate, and latest rectum. So if you drop a line, or if you make a line which is parallel to the y-axis, it will cut the parabola in two parts, 2 points. So x will remain same, y will change. Y will change. So what is y? These two y's are double ordinate. So these two y's are double ordinate. So if this is focus AE comma 0, the x will be AE, y I don't know. We know that x will be AE because you see from 0, 0 to AE comma 0. I am making it at focus because the line which is passing through the focus will be latest rectum. That will be latest rectum. We will have direct formula. So x square by a square plus y square by b square equals 1. So in place of x, we will write AE. We know AE because it is passing through focus parallel to y-axis. So x as AE put, y we don't know. You can put as SL, or you can put as y also. So you have y square by b square equals 1. So what do you get? Y square. I am just rearranging it. Y square will be equal to b square 1 minus e square. Okay. And this 1 y square will be b square by a square 1 minus e square, because we know b square was we already saw b square equals a square 1 minus c square. So 1 minus c square you can write it as b square by a square. So I am writing 1 minus c square as b square by a square. So this will be b raised to the power 4 a square, and take the root. Take the root here, b square by a square. So you get b square and then a. This is b square by a. So what is the length from here to here? It's b square by a. So this y or SL is b square by a, or this is half of the length. How about full length? Latest rectum is the full length. B square by a plus b square by a, or you can say b square by a into 2. So length of the latest rectum, a line which is passing through the focus, cutting 2 points on the ellipse and parallel to axis, 2 into b square by a. This is the length of the latest rectum. You can always write this you know that b square can be written as a square 1 minus c square. So you can write b square as a square 1 minus c square. 1a will cancel. So 2a 1 minus c square. And there is one more thing, which is the focal distance. Focal distance is nothing but the distance of any point on the ellipse from its foci are known as its focus distance. Focal distance. So you take any point, the distance of this point from focus 1 and distance of this point from focus 2. We are talking about focal distances. Focal distance simply means, let me tell you again, this focal distances is the distance of any point on the ellipse from its foci, that is 2 focuses, are known as its focal distances. So this f1, f2, this is d1, d2. This d1, d2 are nothing but focal distances, right? d1, d2 are focal distances. So you just have to find out distance of xy from a is 0, the distance from xy minus a is 0. So let me add few more things here. There are 2 types of ellipse. One is the horizontal ellipse, one is the vertical ellipse. So we have all talked about horizontal ellipse. So what will be the changes when we draw a vertical ellipse? So this is an ellipse. This is x-axis. And then when we make a vertical axis, the major axis will be on the y-axis rather than on the x-axis. In horizontal ellipse, the major axis is on x-axis. Again, my handwriting and my drawing is not very good, so just excuse for that. So we have x square by a square plus y square by b square equal 1, and vertical it will be x square by a square plus y square by a square plus x square by b square equal 1. So just remember that there will be a and b and x and y are shifting places. The vertex of the horizontal axis was what? Minus a comma 0 and a comma 0. A comma 0 minus a comma 0. Now the vertex of this will be 0 comma a, and this will be, because you know the axis we have changed. So x will become y, y will become x. Right? There will be only this change. So focus is ae comma 0 and minus ae comma 0. If you remember, ae comma 0 and minus ae comma 0. And same thing. In many books it's given like this, so I've just taken it. Here, this will be 0 comma ae, and this second focus will be 0 comma minus ae. And co-vertices, these 2 points, co-vertices. So there is one more thing. We always thought that the center will be at C0, 0, but it's not the case. The ellipse can be in any orientation, any direction. It can be like this. What will you do? If the center is x, center is not 0, 0, but rather h and k, so we have to change our equations, our results. So if you have h and k, so x minus h whole square, y minus k whole square, that will remain. Same thing, x and y will become x minus h, y minus k. So when we are talking about horizontal, the things will change on the x-axis. So vertices will be h plus a, foci will be h plus c, second vertex will be h minus a, second focus will be h minus c. So you are adding and subtracting from the x-axis. On vertical, now the y-axis is the major axis. So everything will be done on k. So k plus a, k minus a, k plus c, k minus c. That is k plus ae, k minus ae. And co-vertices are on the opposite axis. So whatever you do at h, you will do at y, or h at k. Whatever you do at k, you will do at h. So this is all about this ellipse. Thank you so much. Take care of yourself.